All right, so welcome to our notes on solving quadratics by square rooting. We also have a little bit of U-substitution in here at some point. If you forgot how to simplify a radical, like for example, simplifying the square root of 50, make sure you watch the screencast from Khan Academy that's posted in Schoology right above these notes. Okay, go ahead and pause the video and try the warm-up. All right, I'm going to show you what you should have gotten. Let's see how this works. Oh, did it. Okay, so if you factor, or if you set it equal to 0 and then solve it, it is factorable. So you're looking for two numbers that multiply to give you 100 and add to give you negative 29. That's negative 25 and negative 4. Your lead coefficient is 1, so you're ready to factor. And then that factors to x squared minus 25 and x squared minus 4, which you can continue to factor it there. So if you want to continue to factor that, you could do 0 equals, and then x squared minus 25 factors to x plus 5x minus 5. And x squared minus 4 factors to x plus 2x minus 2. You could do that. What I did is I stopped and set each factor equal to 0 and solved by square rooting. So I have square root plus or minus, square root plus or minus, and that's why I got 4 total solutions. Also ask you to graph this in your graphing calculator. Go to y equals, put in your original equation right here, and then fix your window so that your y values are seen. And you can see that these are your zeros, negative 5, negative 2, 2, and 5. You could also see your y-intercept of 0, 100 there. Okay. All right, so we are now going to look at some quadratics that we should approach a little bit differently than what we approached yesterday. So what you should notice about these equations is that you don't physically see an x squared and an x in these equations. Okay, so like up here, well, it's an x to the 4th and an x squared, but you don't see both of them in here, right? You don't see an x squared and an x. So if you do not see an x squared and an x in a quadratic, I solve it by square rooting, and so should you. So to solve it by square rooting, what you need to do is you need to isolate it so that you can square root it. So you need to isolate the square, then square root. Don't forget to account for both the positive and negative solution by doing plus or minus, and then making sure you simplify also. So for example here, I only see an x squared in this. I don't see an x squared and an x, so I can solve by square rooting. I can't square root yet because I want to square root this, all right? So first, divide both sides by 4. We have x squared is equal to 3, and now we can solve by square rooting, okay? So square root to solve. You have x equals, and then don't forget to account for both the positive and negative solution that work when you plug them back in. So square root of positive and negative root 3. I said square root twice. So positive root 3 and negative root 3. Okay, moving on to the next one right here. I do not see an x squared and an x, so I can't solve by square rooting. So unlike the other one, I need to get rid of this square before I can get inside that parentheses. So I'm going to square root first. Don't forget your plus or minus. So now I have x minus 3 is equal to positive and negative root 7. And x is still not by itself, so I'm going to add 3 to both sides. And I have x equals root 7 and 3 are not like terms, so we cannot combine them. So you're going to write it out separately. Like you can't say like, oh yeah, that's root 10 or anything ridiculous like that. They're not like terms. So you write down the number you added or subtracted from both sides first. That's 3. And then you say plus or minus root 7. So that's 3 plus root 7 and 3 minus root 7. Which you can just write it as 3 plus. Hey now, you can just write it as 3 plus or minus root 7. Okay? Once again, just so we realize, this is two solutions. X equals 3 plus root 7 and x equals 3 minus root 7. All right, moving on to the next one, very similar to the last one. I want to get rid of this square, but I can't do it yet because this isn't isolated. So I'm going to divide both sides by 2. Also, please notice you do not see an x squared and an x. So that way I know I can solve by square rooting. It is our easiest method. X minus 4 squared equals 18. And now I can square root both sides. So square root, Don't forget to account for both the positive and negative solution that are going to work when you plug it back in. So x minus 4 equals plus or minus. And then root 18 is simplifiable. So I'm not going to write down root 18 right now because I know I can simplify it. When simplifying a square root, okay, I'm going to explain it once, then I'll just do it from now on. You're looking for the biggest perfect square that goes into root 18 as a factor. So if I list my perfect square, I have 1 squared, which 1 goes in everything, so I just don't even list that. 2 squared's 4, 3 squared's 9, 4 squared's 16, 5 squared's 25, 6 squared's 36, so on and so forth. The reason I stopped is because I already passed 18. 18 falls right here, so definitely not this, but I want to see if anything to the left is a factor. You want the biggest number, so make sure you don't just jump to the end, like look left to right. So 16 is not a factor, 9 is. So I'm going to say that root 18, 9 goes in there twice, but I don't do that. I just say root 9 goes in there root 2 times, and then simplify the one that you got from the list, which is a 3. So this is 3 root 2. So plus or minus 3 root 2. And then now I can get x by itself by adding 4 to both sides. Once again, these are not like terms, so they cannot be combined. So you're going to write it as x equals 4 plus 3 root 2 and minus 3 root 2. But I'm going to write it as plus or minus. Okay? Please don't try to combine 4 plus 3 or 4 minus 3. You cannot do that. That's a 3 times root 2. It's stuck to that root 2. It's multiplication. You can't separate it. Okay. This one right here, I only see an x squared, so I'm going to solve by square rooting. I'm going to get x squared by itself first. Subtract 14 from both sides. 2x squared is equal to, that's 8, 3, no, that's bad math, 2, 1, 128. All right, now I can divide both sides by 2. Can't square root yet, right? So we have x squared is equal to, 2 goes into 12 6 times, 2 goes into 8 4 times, that's 64. And now I can finally square root to solve. And I have x is equal to positive and negative. The square root of 64 is 8. And there's your 2 solutions. One thing I want to bounce back to really quickly is the opener. Okay, so what I don't, I hate this, that it's a 4th power. I wish it was a quadratic. But let's just say it was 0 equals x squared instead, minus 29x plus 100. Please don't try to square root this equation. You can't solve this by square rooting. It's got an x squared and an x. We can't use this method that we're using today. Okay. All right, this does not have an x squared and an x, so I'm going to solve it by square rooting, but I got to get this by itself first. So I'm going to subtract 4 from both sides, and I'm going to divide by negative 3. So first, subtract 4 from both sides. Negative 3 times the quantity of x plus 5 squared equals negative 27. Divide both sides by negative 3. I have x plus 5 quantity squared is equal to 9. Now I can square root to solve. So square root, don't forget your plus or minus when solving. I have x plus 5 is equal to plus or minus. This time we do know the square root of this number. We know the square root of 9. Unlike the last, 2 ago, that was root 18. This is a perfect square, so we just have 3. I'm going to subtract 5 from both sides. I have x equals, and then this time they are like terms. I'm going to write it as if I didn't realize that for a second. So I would write the number I subtracted from both sides first, negative 5 plus or minus 3. But I'm not going to leave my answer like this because I can combine these. So we are going to do negative 5 plus 3 is our first solution. Negative 5 plus 3 is negative 2. And then we also have negative 5 minus 3. There's a different color there. Negative 5 minus 3, which is negative 8. And there's your 2 solutions. Okay. All right, next one here. I can square root, but I got to get this by itself before I do that. But notice there's not an x squared and an x, so I'm going to subtract 9 from both sides. 16 equals 4 times the quantity of x minus 2 squared. All right, so now I can't square root yet because that 4 is in front, so I'm going to divide both sides by 4. I have 4 equals x minus 2 quantity squared, and now I'm going to square it to solve. Square root plus or minus, square root plus or minus. I have plus or minus, the square root of 4 is 2, equals x minus 2. And then lastly, I'm going to add 2 to both sides and simplify. So I have x equals 2 plus 2 and 2 minus 2. So you can write it out like this first so that you can make sure you see and hear both answers. And then you have x equals 2 plus 2, 4. X equals 2 minus 2, 0. All right, there are your solutions. Okay, so that's solving by square rooting. And now we're going to look at solving by using what's called U-Substitution. So if you look at these two equations right here, my first thought of them is, ew, 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 ew. Okay, let's talk about what I don't like. I look at number 1 and I'm like, s over s plus 1, a fraction. Ooh, but at least both of these have that fraction, this and this, right? I wish that wasn't there. Ooh, don't I wish that this was like x instead and this was x instead? Because then I'd have 6x squared plus 5x minus 6, and I could solve that. So that's what we're going to do. We are going to use what's called U-Substitution to make it look prettier, solve that, and then bring back the ugly. Okay, that's what we're doing. Now, I said, wouldn't it be nice if this was x and this was x, so it was 6x squared? We don't tend to use x's because a lot of times the problem already has x in it. So what we use instead is the letter u. So it's called U-Substitution. Okay, so we're always going to start off by saying let u equal, and then you're going to write down what you're going to put u in place of. So that's this right here. All right, so that's going to be s over s plus 1. So every time I see an s over s plus 1, instead I'm going to write u. So we have 6u squared plus 5u minus 6 equals 0. And now we're going to solve this. So I cannot solve this by square rooting due to the fact that there is a u squared and a u. So we're going to try to factor it. In order to factor it, it has to be equal to 0. Good. And now I'm going to do a times c, which is negative 36. B, which is 5, and I'm looking for two numbers that when I multiply them, I get negative 36, and when I add them, I get 5. So that would be 9 and negative 4. Don't forget to divide by your lead coefficient of 6, and then simplify either one or both of your fractions depending. So 3 goes in here twice, 3 goes in here 3 times, 2 goes in here 3 times, 2 goes in here negative 2 times. So bottoms up, you have 2x plus 3, 2u plus 3, and 3u minus 2 equals 0. And then you can set each factor equal to 0 and solve. Okay, don't get too excited and move on to the next problem. Subtract 3 divided by 2, you got negative 3 halves. Add 2 divided by 3, you have positive 2/3. So what I was saying was, don't get so excited and be like, circle, move on, because you put u in the problem. U was never in the problem. So now we have to substitute back this s over s plus 1. So we have s over s plus 1 is equal to negative 3 halves. And s over s plus 1 is equal to 2/3. So we have to solve each one of those equations. Okay, this is a proportion. The easiest way to solve it is by cross multiplication. So that's what I'm going to do. Multiplying straight across. I have negative 3 times s plus 1 is equal to 2s. Did I mention that I hate that there's s's in this because they look like 5s? I do. Distribute your negative 3. Negative 3s minus 3 is equal to 2s. I'm going to add 3s to both sides. I got negative 3 is equal to 5s, and then divide both sides by 5. Ooh, a 5s. Isn't that pretty? All right, s is equal to negative 3/5. That's our first answer. And then now we can go ahead and do the second one. So cross multiply. I got 2 times s plus 1 is equal to 3s. 2s plus 2 is equal to 3s. Subtract 2s from both sides, and I have s is 1. Right? No, sorry, s is 2. 1s is 2, so s is 2. So there's your two solutions. S is 2, and s is negative 3/5. I hope to never work with an s again. I don't like it. Okay, let's go ahead and do the next one. So once again, what do we hate about this? Fractions. Ooh, don't like it. There's more than one way to get rid of these fractions here. I could get rid of my fractions just like we did before, multiply everything by x squared. But instead of doing it that way, I'm going to show you how you can use U-substitution. So to decide what you're using for, I'm going to show you both ways actually, and then I'll let you do the next one on your own, okay? So, or the next few on your own, you can check back to see how you did. So here, I'm going to let u equal. Now, if you look, I don't want it to be 8 over x, because then what am I going to do right here, right? And I don't want it to be 1 over x squared, because then what am I going to do here? So what we're going to do is we're going to make it 1 over x. And then now I can substitute it in. So if I substitute 1 over x here, that's the same thing as u squared. Plus, if I substitute in 1 over x here, that's 8u plus 15 equals 0. Not cross multiply, make your organizational x. That's 15 and 8, which is 5 and 3. So you have u plus 5 times u plus 3 is equal to 0. So you have u equals negative 5 and u equals negative 3. Remember, not your answers, but now we can get our answers. 1 over x is equal to negative 5. 1 over x is equal to negative 3. You could solve this the exact same way. Like you could make this a proportion and cross multiply, okay? Or you can say multiply both sides by x, right? Multiply by x. Multiply by x. Those cancel. And you have 1 equals negative 5x, and then say I got to divide by 5 to get x by itself. Sorry, negative 5. So x equals negative 1/5. But if you look at that pattern here, that means x is equal to negative 3 here. Sorry, negative 1/3. But you could cross multiply. You could multiply both sides by x and then get x by itself. Okay, so if you look at the last few, you have 6 problems to try on your own. I want you to pause the video, try the last 6 on your own, and then either go to the answer key on Schoology and check to see if you did them right, or just look at this video. All right, here you go. Here are your answers. Let me try to think of things you might get stuck at. Number 1, making sure you get it equal to 0 first before you factor it, but not square rooting. Number 2, you have to cube root to get x by itself. In the future, we'll find imaginary solutions with that too, but for real solutions in the directions, just x equals 2. Number 3, you can solve by square rooting. Number 4, I used U-substitution and I let x be equal to the square root of x, which is the same thing as x to the 1/2 power. So if you let u equal the square root of x, then that means that this square root of square, right? A square root is the x squared, is the u squared. And then on the last one, I let u equal x to the 1/3. I said I would do this 2 ways, and I forgot to show you the other way. So the other way of doing this problem, I haven't even practiced it, but I'm going to see if it works out okay, is that you could get rid of the denominators by multiplying everything by the LCD like we have in the past. So multiply everything by x squared, right? And then even this, right? So then you have, let's try this, x squared and x squared cancel. That's 1 plus x, not x squared, but x and x cancel, so that's 8x. And then plus 15x squared equals 0. reorder this. 15x squared plus 8x plus 1 equals 0. Two numbers that multiply to give me 15 and add to give me 8 are 5 and 3. Divide by the lead coefficient, which is 15. Simplify each fraction, that's 1/5. That's 1/3. Bad math. So 5 goes in there once, 5 goes in there 3 times, 3 goes in there once, 3 goes in there 5 times. So that's 3x plus 1 times 5x plus 1. Set each factor equal to 0 and solve, and you get -1/3 and -1/5. So whatever floats your boat with that. Okay. All right. Hope that helps, and let me know if you have questions.